Hello everyone. Good morning, good afternoon, or good evening, depending upon the time zone you are in. So we are really excited to have you all joining this session. And today we are going to talk about how Amazon OpenSearch Serverless can help you to get real-time analytics of player insights. I am Prashant Agrawal, Senior Search Specialist Solution Architect in AWS. I primarily focus on Amazon OpenSearch Service. I have spent more than 10 years of my career in search, specifically around the Elasticsearch and now the OpenSearch. With me, I have my colleague JJ. So JJ, would you like to give a quick introduction before we get started?
Absolutely. Thanks a lot, Prashant. My name is JJ Johnston, and I am a senior analytics specialist with AWS. And I do focus on OpenSearch, but I focus more on the holistic picture in terms of helping customers make the best use of the analytics suite of services here at AWS, especially with where OpenSearch fits into their business needs and their business use cases. I've been here with AWS for 2.5 years and Amazon for 3.5, previously working on the Alexa data lake, a couple of AI/ML startups, as well as some fintech companies in my past. And I'm excited to be here with you all today.
Thanks, JJ. So we have a really packed agenda today where we start off with a quick introduction to OpenSearch and OpenSearch Service and talk about OpenSearch Serverless. Get a bit of deep dive into OpenSearch Serverless to understand fundamentals and a bit deeper onto the security aspect within the OpenSearch Serverless. Next, we will talk about the need of analytics in gaming industries, followed by a demo showing how the player insights and interaction could help you to drive more business within your gaming industries. After that, we will go and talk a bit around what's new happening in this OpenSearch space, followed by a quick next step. So before I get into the details, I am reminding you all that we have experts online in this session. So if you have any question in between, feel free to drop in those questions under Q&A section. You will see a little question mark symbol on your screen. So that's where you can post your question over there and we will get those answered in real time. So what exactly is OpenSearch? So OpenSearch is an Apache 2.0 licensed search and analytics suite comprising OpenSearch, OpenSearch Dashboards, and a suite of plugins providing advanced anomaly detection, alerting, observability, and security analytics capability. And as OpenSearch project is open source, so we have seen a tremendous growth in terms of the project downloads since its launch. So like we launched in July 2021. So we have seen like greater than 200 million downloads, and OpenSearch has been into the top 4 search engine in terms of the DB engine ranking. And another thing is like we have a lot of partners who are actively contributing and collaborating with OpenSearch project to kind of keep the development happening into the open source world. We have 55 plus partners, which is growing at tremendous rate. And also we have seen 200% growth into the pull request, which has been merged into the project. And when we talk about OpenSearch being offered as the service, so we have multiple service providers. So like, for example, AWS is offering the service as Amazon OpenSearch Service. Then we have the Ivan offering it on Azure and then Bonsai offering it on GCP. Now, when we talk about the OpenSearch, so we see a really two use case with respect to the OpenSearch. So first one being the search. So you might want to go to an e-commerce platform to find the product quickly, as well as you might need the personalized recommendation provided by those search engine as per your interest. Then on the other side, when we talk about the log analytics, you might need to ingest tons of data, which is typically your log data. Here, log could be used to identify problems as well as help you to run analytics on those data. So today we are going to focus more on the insights we get from the player metrics in games, but just to highlight, there could be other cases as well for analytics. So for example, you may want to find out fraud or you want to make sure that you protect your application and services from denial of service attack. Now, most prominent things happening nowadays is all about vector engine. So when you tie up this search with vector engine, you may want to have conversational search using the chatbots, or you may want to use this for filtering and recommending product, which is most relevant to the users. Now, if I try to tie this with the gaming data, it could be the chat happening amongst the players, or it could be showing similar players who might be of same interest as you. And when we talk about vector engine capability and the logs, it could also be used to recognize the patterns for fraud detection, such as if there are players doing cheating, or it could be inference coming out of natural language during the conversation among the players. So how exactly the search works? So here the typical data flow and consumption pattern from users or operators using the OpenSearch dashboard to interact with the log data. So how you exactly use the OpenSearch is like you load the data through REST API, which is formatted in JSON, and then you can have the same structure or the structured data, which is going to represent your documents, or it could be your machine data. Then OpenSearch parses and analyzes those data and organize documents into the reverse index designed to make search faster. And OpenSearch uses the Lucene under the hood. Then user can search and analyze through REST APIs. So, or you can use your favorite programming language clients, or you can use a visualization and discovery tool called the OpenSearch Dashboard. So typically when we talk about the log analytics workload, so they are write heavy and they are kind of append only load where you might be generating a lot of data which you don't really have like a way to update those data sets in real time, but it's like continuous flow of the streams. So how does OpenSearch service comes into the picture is like it gives you a fully managed service that makes it easy to deploy, operate, and scale OpenSearch cluster in AWS cloud. And AWS take care of undifferentiated heavy lifting and enables you to run OpenSearch in the AWS cloud by eliminating the operational overhead and reducing the cost with integrated security and compliance that meet and maintain high security for authentication, authorization, encryption, etc. Then observability is what it's kind of the thing what everyone is talking about, where you can use the OpenSearch to systematically detect the potential threats and react to a system state through an open source solution for observability. Last but not the least, cost for those log and application data increases as the data grows. So with OpenSearch service, you can optimize your time and resources for the strategic work by using different storage tier for your data. So with this managed service, customer gets a lot of flexibility in terms of configuration and management options, but they also need to spend significant amount of their time and efforts on right sizing the cluster or managing the indexing and sorting strategy, as well as defining the data lifecycle. So that's where OpenSearch Serverless comes into the picture. So OpenSearch Serverless was announced GA as this year January, and it makes it easy for you to run large-scale search and analytics workload without having to configure, manage, or scale OpenSearch cluster. Serverless also take care of undifferentiated heavy lifting of managing indexing and sorts in your cluster by automatically provisioning and scaling the underlying resources to deliver faster data ingestion and query responses. One of the key tenets while we were working on development of serverless was to keep the same API as it's there into the open source OpenSearch and provision OpenSearch service. So this way, customers do not really have to rewrite their application to interact with OpenSearch serverless, as well as avoid rebuilding the ingestion data pipeline with few changes in configuration. And at the end, you only pay for the resources what you consume for your workload, making it a cost-effective solution to run OpenSearch at scale. Then how exactly are the what are the different fundamentals blocks within the OpenSearch serverless? So basically, just like you have the clusters into your provision service, so we have a concept of collection. So collection is kind of a lightweight cluster which comprises set of indices holding the data. There are different security mechanisms in OpenSearch serverless, such as defining the encryption policy, network policy, and data access policy. We'll talk in detail in the next slide for the security mechanism we have with the serverless. And then there are three kind of collection what serverless has. So if you recall my earlier slides on use cases, so we have the traditional use case of log analytics and search. So that's how serverless collection are aligned as well, where you have the time series and search as type of the collection. And now with the integration and demand from customer around vector engine, we have introduced third collection type as vector engine. So hold on tight for that one, and we will talk about that in what's new section towards end of this session. Now talking about how exactly the compute and the capacity unit works. So this is kind of a new concept in serverless. Here we have OCU. OCU is kind of OpenSearch compute unit, similar to what you have the nodes in OpenSearch service. Each OCU comprises of 6 GB of RAM and 1 vCPU, which can store around 120 GB of data in it. And you have an option to configure max OCU, which help you to control cost, and they are automatically provisioned and scaled depending upon the workload. Lastly, those OCUs are shared across the collection. So if collection uses the same KMS key for encryption, so in that case, those OCU would be shared by utilizing the efficient resources in your collection. And when we talk about the architecture within the OpenSearch serverless, So we have sort of created a cloud native architecture where your data is stored into Amazon S3. It's kind of decomposing the monolithic open source service to different microservices. So today, if you look at your data node, it will run the ingestion as well as search. Serverless separates out the indexing component from the search component, with Amazon S3 being the primary data storage. This decoupled architecture let you scale search and indexing function independently of each other, and it also comes in with built-in hot form tier, particularly in the log analytics use case where you are more focused on the recent data while the older data could be stored in warm tier. Then when we talk about the availability and or rather the high availability, so in that case, there are active nodes to handle the traffic. And in order to ensure HA, it also launches a standby set of nodes in different AG for indexing and then replicas for the search. Then we build the security stack from ground up, and now we have separate secure service mesh for the customer traffic as well as between the microservice. At last, it also comes with the OpenSearch dashboard, which you can use to create visualization and dashboard to interact with your data. Next, I'm going to talk a little bit detail on the security, like how exactly the security has been redefined and rewritten with OpenSearch Serverless. So at first, you have an option to define the encryption key for encrypting all of your data. Whether your data is at rest or in transit, you have an option to define your own KMS key, or you can use the AWS managed KMS key for that one. Next, you have the network policy, which could be defined for your collection to make sure like whether your collection should be accessible on the public internet or it should be accessible on VPC endpoints. And at the end, you define the data access policy, where you set up the permission either at the index level or at the collection level, and then use IAM or SAML based authentication for logging into the OpenSearch dashboard. So with that, I would hand it over to JJ to go a little bit deeper on the like how exactly the log analytics plays an important role into the gaming customer and gaming industries. Over to you, JJ.
Thanks a lot, Prashant. We've heard a lot about, how OpenSearch, works and what works underneath the hood, but really where we find a lot of value is bringing that side by side with your business needs and your business use cases. One AWS customer, Supercell Culture, Supercell has a great culture motto of being, hey, analytics can't make a great game, but you can improve it. And this makes us really think about, okay, what can we do with analytics on our games, and why do we need it, right? And if we think about a couple of different things that we can go ahead and work with here, is one, we want to think about more engaging games. How do we make sure that we're targeting our customers in the right way based off of their interactions? Also, based off of those customer interactions, can we identify any outliers, any sort of fraudulent behavior, or do we need to look into, maybe somebody that's abusing the system, et cetera, there as well too. And that also ties in strongly with how do you go ahead and take care of performance monitoring and reporting, so that you can scale accordingly, especially when you start thinking about bringing in marketing events or special in-game events there as well too, to identify how those are performing, and that your systems are responding appropriately. And nowadays, especially with monetization being a huge part of the gaming ecosystems, from both in-game real currency transactions as well as virtual currency transactions, monetization is a huge piece, and understanding what is interesting to your customers and exposing that in a quick real-time basis is crucial here. And this is all covered by analytics, and OpenSearch can help identify a lot of these and help expose those for you as well too. When we think about engaging games just a little bit more in depth, really, we want to make sure that you're developing your games based off of those metrics that you're seeing, and the design is really taking that into account there as well too. And by going ahead and taking the data that you see of how people are interacting with you, you're able to go ahead and increase your engagement, attract new players, and understand where you want to go ahead and market, going forward, or expand going forward there as well too. If we take one step further and we think about fraudulent and player investigations, right? Looking at cheaters and looking at abusers, but also looking at, various gameplay reviews as well too, because that's also a big, item nowadays. I mean, I'm sure a lot of you folks have, heard the stories around review bombing and things like that. So understanding, what are actual reviews and investigating into that, and even using this to identify, potentially fraudulent customers that you can win back is also a great use of analytics within games and within OpenSearch there as well too. Performance is a big key one, right? With OpenSearch, especially because when you start thinking about your time series data, you have all of this player metrics coming in real time. How many logins, how many new user registrations, how many times has a customer opened the app there as well too. It really lets you understand your trends, right? Especially around, are your users logging in right after school or right before bed or before they go to work, things like that. But combining that in-game metrics along with the latency there that you're seeing within your own services can help you go ahead and identify if you need to respond appropriately to certain time periods. And this all gets exposed as well through the log analytics and those time series trends that you can expose with OpenSearch. And then finally, we talked a little bit about monetization. OpenSearch typically powers, the input into your inference for models that are actually going to go ahead and do targeted ads or potentially encourage purchases from customers that are in game there as well too. But this all comes down to being you want to do it faster and you need to do it accurately, right? And so you need to make your changes to improve your customers' retention relatively quickly. You need to get those insights as quickly as possible, and you need to make sure you're doing accurate analysis on your data when you go and make changes or reach out to customers in order to get the best ROI for your individual actions. So let's see how this can actually go ahead and work within Amazon OpenSearch Serverless, and how the whole picture comes into play through a quick demo. Now, the basic demo that we're going to show today, just to go ahead and get you all started, is a simple demo of bringing data in from your game data and getting it into OpenSearch Serverless using Kinesis Data Firehose as well as Kinesis data streams to go ahead and get that data in. Now, typically what you might have happen is your individual mobile applications or your game servers or even the AWS SDK will generate these events, push them into Kinesis, Amazon Kinesis data streams, which is a high throughput message store system. And then those will be picked up by Kinesis Data Firehose, which is a delivery service, and get that pushed into OpenSearch Serverless efficiently and quickly at a very cost-effective mechanism there as well too. Additionally, it's very fault tolerant in case you're getting messages that are malformed or error out for whatever reason. We can store those back into an S3 bucket to process those at a later time or see if there's anything else fraudulent going on here. So let's go ahead and switch over to the console and take a look at what we have as part of this particular demo. So I'm going to switch over on my screen to the Amazon OpenSearch service within the AWS console. This is a basic landing page here that we can go ahead and see all of the different services, all the different pieces of the OpenSearch service that we have from both provision clusters and serverless clusters. Plus, it's really quickly to go ahead and easy to quickly to go ahead and get a new cluster up and running or even a serverless endpoint. But the one benefit of serverless is you don't have to think about sizing, et cetera, to get that going. So let's see just how easy it is to go ahead and get started with OpenSearch Serverless. So I'm going to go ahead and come into my OpenSearch Serverless dashboard, and we see that we actually already have one collection open and running. I'll go into that a little bit later, but we're going to create a new collection here just so you can see how quickly and easy it is to get this going. So as I create a collection, I'm going to go ahead and give it a sample name, and I'm going to go ahead and give this a demo games environment, right, for my collection. In this case, because I'm dealing with player data that is coming in a time series manner, I'm going to leave this as a time series type of collection type. If you want to do a search one, you can select that as well too, or vector search. And I'm going to leave it as an easy create as my security setup. And what that's going to do is that's going to apply access controls to the cluster and applying all of our best practices that we've learned over time, making it easy for you to get started, including what KMS key to use and data access controls that you have there as well too. So as I go ahead and select next, we'll see all of those details. We'll see which principal has access to this cluster and to the data here as well, which is what I'm logged in as here. And I can go ahead and submit and create that cluster relatively easily. It will only take about 3 to 5 minutes to go ahead and get that up and running. But in the meantime, I'll show you what it actually looks like once you actually have a collection up and running. So I've come back to my list of collections here, and I can see that my peculiar KDS collection is actually already created. And this is for a fictitious game that I have called Peculiar Magicians. And we're going to take a look at some of this data that we can go ahead and analyze for that particular game here. So I can get to our OpenSearch dashboards quickly by going and selecting the dashboard link here directly. So I'm going to select my dashboard link here and open it up, and it lands me into the base landing page for the OpenSearch dashboards. And we can see that it's set up for this particular collection, the peculiar KDS, and I can quickly and easily go ahead and start discovering data that I have within here. So as I open up my menu on the sidebar, I can quickly discover data by selecting this discover link, and immediately what I'm seeing is all of the data that I'm getting within the last 15 minutes, right? So in this last 15 minutes, I've gotten 87,000 new documents coming into here, and we can see that these are all JSON style documents with keywords and values here that I can quickly go ahead and see. If I want to look for a different time period, it's really easy to go ahead and make this change for my time period to from minutes to maybe 1 hour ago, and going ahead and update that. We can see what the data is for the last hour. We have about 340,000 hits. We have a little blip here where my data generator was down for a little bit, but you can quickly and easily identify that as well too. But you may be thinking, okay, it's great. I can see all of these individual, items, but it's not that easy to parse and actually visually break it down. So this is where you might want to go ahead and select some of your available fields on the left side here. So what we see here on this left side is not only the index pattern that we're looking for. So we're looking for all of our peculiar indexes here. And then I can select some available fields. So maybe I want to look and see what items are being purchased in game by which platform and maybe by which region. So I'm going to go ahead and select the item name here, which goes ahead and includes what item name I've purchased, or the users have purchased, what platform it's on. So we have a combination of Xbox and iPhone and Android, and even Unity Editor for some of our developers there as well too. And then I can go ahead and select maybe the country ID here, which I think is just the region ID for, no, here's the country ID here as well. So we have the United States, France, and Mexico. And so we can quickly see a tabular version of this data without doing much here as well. But the power of OpenSearch isn't just being able to quickly visualize this. It's the ability to go ahead and do free text queries on this data to find matches without needing to write any sort of SQL, etc. So maybe I'm really interested in a unicorn hat. So I'm going to go ahead and just search for unicorn here, right? And search this in my search bar up at the top. And now what it's actually done is it's gone and matched all of my unicorns in my data set, in keeping all of my selected fields here, and adjusted the number of hits relatively quickly without me having to specify what column I want to work with. I can quickly change this. Maybe I'm interested in the iPhone users, right? And so I'm going to go ahead and search for iPhone users here as well too. And I can quickly go ahead and find all of my iPhone users here relatively easy. It's that simple to work with. Now, this is great for, DevOps folks or developers or people who just want that flexibility to go ahead and do a search on your data. But maybe you want to go ahead and present this to an end business user who doesn't want to have to worry about searches, but just wants that high level dashboard of the data that's important to them and the metrics that they're seeing. And this is where we can go ahead and end up working with a dashboard. So I'm going to switch over into my Peculiar Magicians Hub, which I've actually viewed recently. This is a dashboard that I've created. I'm going to go ahead and open that up. And we see that we're looking at data for the past hour. And some things that I've got here immediately pop out to me is one, what's my total logins for today, right? How many people have logged into the application? In this case, we got 88,000 people about logging in. We have over 3,000 new registrations. I can see some popular items purchased here as well too, and a nice word cloud, as well as the amount of purchases over time for this too. So we can see a number of different metrics and data points that allow us to quickly go ahead and expose this data for various time periods. So this is for the last 1 hour. Maybe I want to go ahead and adjust this to do a larger time frame. So I'll go to the last maybe 3 days and see what kind of data we have. Now I haven't been generating data the entire time, so we have a little bit less. Let's actually go down to 1 day. Today, just to give that a nice little update. So we have a smattering of spikes of up and downs because I'm not actually generating the data all the time for this, but we can see that it's relatively responsive in terms of quickly updating the dashboard with the metrics that we're looking at and going ahead and responding with even larger data sets. So, I mean, I probably have a couple tens of millions of records behind this for the past 2 days because I'm generating quite a bit of data, and we can see all of this information displayed here as well too. Now, if you also want to go ahead and work with this data and expand this dashboard, it's relatively easy to go ahead and do that as well to expose additional data sets. So let's go and quickly add a new panel to this dashboard that we can go ahead and expose around the total amount of revenue for particular items that have been purchased. So let's go ahead and edit this dashboard. And let's go ahead and add a new panel here. And in this case, I've actually gone ahead and created a panel called Top 10 Items by Revenue. So I'm going to go ahead and select that. That's added automatically here. I've got this added right here on the right side. So let's go ahead and bring this over. I'm going to resize it first. Pop this up. There we go. And I have my top 10 items by revenue. We can see that the unicorn hat is the most popular item, followed up closely by the love hat there as well too. So this is just another easy way for you to quickly see metrics that are coming out of your games and understanding what's important to your end users and giving you that insight needed to go ahead and react accordingly here as well too. One last thing I would like to go ahead and just show and just indicate is it is easy for you to get this data into OpenSearch Serverless or even OpenSearch provision clusters there as well too. We talked about using Kinesis data streams with Kinesis Data Firehose, getting that into OpenSearch, but let me show you just how easy it is to go ahead and run. So right now, what I have running here is I have an individual. I've switched now over into the Amazon Kinesis dashboard, and I have one data stream and a couple of delivery streams. My data stream is that persistent message store that's going to keep all of my metrics and all of my data coming in. So we can actually see that we have quite a few messages coming in. We've got about just about 100 kilobytes a second coming in. We have quite a few messages coming in there as well too. But the Kinesis Data Firehose is really where the magic occurs. Kinesis Data Firehose will pick up this data for you automatically off of the Kinesis data stream and send it to OpenSearch for you relatively quickly. If I take a look at my delivery stream that I have set up for my current test data, I see that all I've selected here are what my source is, which is peculiar KDS, and then what my destination is, which is the collection and the index that I want to send it to, as well as some buffer hints. And we can see that we're actually sending a number of different metrics here as well too, in terms of about 300,000 messages a minute. Sorry, 30,000 messages a minute or so. Which is relatively good throughput, from my opinion. I'm only producing 100 messages a second right now, which aligns very, very nicely. So let's create a new delivery stream just to show how easy it is to go ahead and get this there. So with the creation of a new delivery stream, I can select my source, which is the Kinesis data streams, and I'm going to select my destination as the Amazon OpenSearch serverless endpoint here. And as soon as I go ahead and select that, I choose what my source location is, and my Kinesis data stream is peculiar KDS. I can give it a custom name for this delivery stream if I want. If I want to do any transformations before I get that data into OpenSearch, I can go ahead and do that. But in this case, I'm going to leave everything as is, and I'm just going to go ahead and select my endpoint here, and we can see we have the new endpoint I just created earlier as there as well. But I'm going to select peculiar KDS as my location. I'm going to give it a index name here as well, which is going to be demo index. And then I can go ahead and submit this. And if I have a private OpenSearch endpoint, then I need to go ahead and select my VPC. But in this case, it is public. I'm going to back up all of my failed data into S3. So I'm going to go ahead and put this down into my demo assets bucket. And then I can go ahead and create this delivery stream and submit that. And it's that easy to get that data going and running into OpenSearch for you to go ahead and start working with and putting into your dashboards here as well. So let me take a step back and come back into my demo here, into my presentation. And hopefully you were able to see that we were generating data, we were putting it onto the Kinesis data streams, we were getting Amazon Kinesis data Firehost to grab that data off of the Kinesis data streams and push it into OpenSearch serverless, all by just us saying, hey, what index do we want to send this to? And then from there, being able to quickly and easily work with that in dashboards and see that data updated in real time, especially for cases where you have games and you need to be able to react quickly, especially for in-game events, in-game marketing, live events that might be going on, there as well too. And with that, I'm going to pass it over to Prashant once again to talk a little bit about pricing and some of the new features and capabilities of OpenSearch and OpenSearch Serverless.
All right, so thanks a lot, JJ, for the excellent demo. And then I hope you all got how easy it is to configure and start with an OpenSearch serverless collection, which could get started. You could get really started in a couple of minutes. So now let's see how does the pricing works within the OpenSearch serverless. So if you look at the OpenSearch service pricing, it is going to be based on your configured instances, additional overhead for HA, then ultra-warm node cost for leveraging the hot and ultra-warm storage tiering, and then you add some buffer at the end. Whereas when we talk about the OpenSearch serverless, so customers are charged by indexing and search OCRs along with the storage cost, which is the S3 storage. So JJ, could you please hit next on that one? Yeah. So on the serverless side, you are charged by the indexing and search OSU along with the storage cost, which is the S3 storage. And if you look at the charts at the bottom, serverless pricing is not going to be constant and it will have peaks and valleys depending upon your workload. Whereas in managed service, you see a flat cost depending upon what you have provisioned. So what next or what's new we are seeing into the OpenSearch or into the OpenSearch serverless is, so recently during the New York Summit, we announced a new offering as vector engine for Amazon OpenSearch serverless. So vector has been a hot topic nowadays where like if you want to run any sort of semantic search or if you want to use your vector for generating or kind of a generative text for the RAG use case where you want to do the retrieval augmentation generation. So that's where the vector engine as the new collection type comes into the OpenSearch serverless. It is also easy to use where you can get started with simple API and you don't really have to worry about planning any sort of capacity or managing the scale. And the thing is, it can help you to store and search billions of vectors in a couple of milliseconds. The another advantage of using the vectors engine with OpenSearch serverless is like you can have the hybrid search. So basically like OpenSearch is meant for the rich search and ranking capability. And here you can combine the text and vector search for the best relevance. So that's what we call it as like best of both worlds matches. So when you look at the traditional OpenSearch, you have the BM25, like best match 25, which is used for generating the relevance. And then with the KNN plugin introduction within the OpenSearch serverless, you can get the similarity based on the KNN score. Then by using the OpenSearch serverless, you can combine both of these scores to get the hybrid relevance with best of both like BM25 as well as the KNN. So that is one aspect of hybrid search. And then there are second aspect as well, which I want to focus more on the hybrid search is like the query patterns or the query format. So like you might want to use the OpenSearch for storing the vector, or you might want to use any other vector database to store those vectors. But you might also have the metadata associated with those vectors. So for example, if you are indexing any sort of journal documents, it might have the title, tag, description, or even you might want to actually store the chunks of those data within that particular storage as well. So that's where OpenSearch outstands, where you can store the vector data as well as the metadata into the same document. And the second thing is you can run the hybrid query where you can have the KNN query for your vector, and then you can have the pre and post filter for running the filter around the metadata. Then we have basically the auto scale within the vector engine for OpenSearch Serverless 2, where your resources will be scaled vertically and horizontally to provide you the best cost and performance combination. And then at the end, it comes with the enterprise grade security. So the security is kind of same what we talked earlier with respect to the OpenSearch Serverless, where you have three mechanism for the security, like encrypting your data, then defining the network access policy, and then kind of defining the data access policy for more granular control. Next, we're going to talk about like what exactly we are running. So we are running some sort of campaign where you can move from the self-managed to the open source service. So here, like customer run the open source analytics infrastructure on premises or self-managed in the cloud, provisioning, operating, scaling, and managing the open source software is a really tedious job, time consuming and expensive. So you need to worry about operational efficiency issues such as hardware and software installation, configuration, patching, backup. Then you also have to take care of different security and compliance standards, like you want it to be PCI compliant or HIPAA compliant or different security mechanism what you might need. So what the customer want is they want to spend time innovating and building the new application which can create the real business value, not managing the infrastructure. So the most straightforward and simple solution for many customers who are struggling to maintain their own OpenSearch, self-managed OpenSearch stack at scale is to move to a managed service like Amazon OpenSearch service. So here the main thing is like you get different benefits by moving to the managed service. Like you don't really have to worry about managing and maintaining the infrastructure. You don't have to do any sort of capital investment on purchasing the hardwares. And then you can add like new features as it comes into the service over a period of time. So like for example, the vector engine, which has come up as the new feature of functionality, you can simply start using new feature and functionality in no time. So what exactly we have in this program is, so if you go to the next slide, so the core of program is kind of a free 2-day deep dive workshop to help you with the migration. In this workshop, we walk you through the process of migrating data to Amazon OpenSearch Service. We discuss about on what basis and what kind of instances you would really need depending upon your workload, and in general, kickstart the process of migrating the workload. Then for customers requiring more hands-on assistance, we also have a variety of ProServe launch offering. So for example, we have a Solar to Amazon OpenSearch service offering, or like self-managed Elasticsearch or self-managed OpenSearch to the managed OpenSearch service offering. Then we also have training along with the AWS partners that you can leverage. Then in terms of the resources, we have the specialist team within AWS who has created a number of outstanding training videos and resources targeting for helping the customer get up to the speed on the service. And lastly, AWS investments in the form of AWS service credits or partner investment, so which are intended to help customer offset one-time migration expense such as the labor, training, and running parallel environment for a certain duration. So with that, I think that's a wrap for the presentation, and now is the time for Q&A. So I will probably see Bob if we have any question around that, but I just want to highlight one more thing, like we have a survey link at the bottom right, and I think Bob is gonna put that link on the chat too. So do complete the survey as that will help us to get better, like what better we can do in this session and what better we could have done in this session versus what better we can do in the future. And let's see if we have any questions.
Prashant, I've made note of a few questions that we had come in today. So first question we had was during JJ's presentation. So JJ, question was, can they get access to the sample data, or how can one use the sample data?
Yeah, great question. So for this particular item, we actually use the Kinesis data generator. The Kinesis data generator is a free open source tool. It's based off of Faker.js to generate random data based off of a series of configurations that you provide in JSON format. I can go ahead and share a link to that in the chat here about that, but it is available online. And then we can also make available later what the sample structure for that was as well too, which highlights what the device type was in the region there as well too, and the different weightings there as well. So you can really try to mimic what real world data would look like for you at a scale that you might not be able to always produce manually here in this case. But we can go ahead and share that, and I'll drop that into the Q&A right here as well too.
Yeah, and JJ, if you could share that in the chat to everyone, if you have resources you want to make available to all, that'd be great. Prashant, question for you or to JJ. How should a customer partition their data across collections? Should it be one collection per game?
Yeah, so I can take up that question. So here the data partitioning strategy could be on different factors. So the one factor could be like how exactly you want your users to allow searches for that data. If you want like they should only be able to search one data or like one game at a time, then in that case it's ideal to have those data across the collection so that like put all the data for one particular game in one collection and then kind of segregate on that basis. But if you have any sort of requirement where you want to do cross search across multiple games and then generate the analytics, in that case you might want to put up all the different games data within the same collection, because like if you want to search across collections you cannot do that, but if you segregated different indices within the same collection, then you can still perform the cross index search within the same collection.
Great, thank you for that, Prashant. Next question was, how long does it take for the service to scale?
Well, so I can probably take up that one and then I will leave maybe next one to the JJ. So when we talk about the scale in or scale out, so there are various parameters what we monitor or observe during the scale in or scale out operations. So those parameters are specifically around the CPU, memory, disk, and the shards. So typically, if you just talk about in terms of the timing perspective, so the scale out or scale in can happen as quick as like 5 to 10 minutes. And the thing is, once so basically we monitor all of those metrics in real time. And once those metrics breaches to a certain threshold for any of those CPU or memory disk, etc., then we will trigger the scale out or scale in operation. So the short answer is like it should be in like 5 to 10 minutes. And once it breaches, it could be like, so basically like we're not just capturing one data point, we will be capturing like 3 to 5 different data points to decide like whether the scale out or scale in has to happen. And that's why like it might take around 5 minutes to scale out or scale in.
Thanks, Prashant. JJ, question for you. Are you familiar with the game analytics pipeline solution, Kinesis to S3 to Glue to Athena to QuickSight? And could you compare or contrast that to the OpenSearch implementation?
Yeah, absolutely. A lot of this comes down to speed and delivery of data. The Kinesis to S3 with Glue and then Athena and QuickSight, or even Redshift and QuickSight, is what you would consider as part of a traditional data lake approach towards working with your data, where you're wanting to combine large amounts of data, not necessarily just real-time game metrics there as well. It is slightly more cost effective, but you are dealing with an increased latency in terms of working with that data and making that available. Whereas OpenSearch, when you have the OpenSearch pipeline and pushing data into there, you can really get that data available as quickly as you kind of want it, right? Within milliseconds as well. This particular one that I showed has a 60-second delay, just because that's Firehose itself has a 60-second delay. But you can get the data into Redshift, into OpenSearch extremely quickly and respond in real time. Whereas QuickSight, especially from a dashboarding perspective, typically requires you, especially to take use of their caching mechanism, to only be updating every 15 minutes unless you're going to the source each time. So it does come down to speed of access there. And then QuickSight is also a lot more structured in terms of your dashboarding. Like once you put your dashboards up, they're pretty set. You don't necessarily have that full free text search capabilities like you do within OpenSearch to really find values across multiple fields there as well. And OpenSearch is much more powerful at that kind of time series perspective. So hopefully that kind of gives you a perspective. A little bit of it is around speed. A little bit of it is around how you want to go ahead and present your search and analysis capabilities.
Great. Thanks, JJ. Question for you, Prashant, given that you just blogged on this subject, and I'll drop a link to this blog in the chat for everyone. But the question is, what security features are implemented in OpenSearch, and how can they be configured to meet specific organizational needs?
Yeah, so when we talk about the security within OpenSearch or with the managed service or the OpenSearch serverless as well, so I would probably boil it down to two different things. One is like if you're looking at the security of the data, or we are looking in terms of the security standards. So if we talk about the security of the data, so then as I mentioned, like there are three different ways of securing the data. So one is like you can have your KMS key to encrypt the data, or you can use the AWS managed key to encrypt the data. So that's where the encryption works. And the second thing is you can protect at the network level, where you can say like you want your collection to be created within a VPC, or if you want your collection to be available over the public internet. Then third type of security is the data access policy, where you can define the granularity at the index level using the OpenSearch serverless, where you can say like certain set of users or roles should have the permission, like, or a read permission only for this set of users, or this for this particular index. So that way you can define the data access policy at the index level and give a dedicated access to certain set of users or groups or roles. So that is one way of the security what I can interpret from this question. And then second set of thing which could be coming in terms of the security is the different standards. So as I mentioned, like OpenSearch service has the different security standard compliance like HIPAA, PCSI, and then FedRAMP, etc. So then probably like if you're looking on that front, we can go even deeper, or maybe like Bob, if we can have, well, if needed, we can have a follow-up session to understand what exactly security meant to this particular customer, and then we can go deeper, like whether it's specific to the standards or whether it's specific to the data.
Great. Thanks for that, Prashant. And to the attendee, we'll be following up with links after today's presentation. And thank you again for registering. And then, of course, reach out to your AWS account team for any follow-ups, but also you can respond back to the follow-up email. And it looks like this is our final question for today. Are there any considerations regarding loading all the data into a single collection? And is there a size limit?
Yeah, so for that, actually, I dropped a link about the limits what we have within the serverless. So if you talk about the single collection limit, so we are supporting up to 1 TB of size of collection today, but that's gonna change in future. So we're gonna add more we're gonna add support for more data size as well. But the thing is, if you are looking for like what exactly the limitation of the size we have on a collection level or at the index level, so then you can have a look on the limits page within the documentation which I just dropped.
Oh, and one final question is vector engine support for OpenSearch separate product or service from OpenSearch Serverless?
No, so vector engine is part of the OpenSearch serverless. So it's the third collection type within the OpenSearch serverless console itself. So probably like if you saw the demo when JJ was talking about creating a collection, so we had three options like time series, search, and the vector engine was there as part of the preview. So it's part of the OpenSearch serverless. But in general, if you talk about the vector, so basically vector capability within the OpenSearch has been there for last, I guess, 3 to 4 years. Like that was available as part of the KNN plugin. That's already there into the core of OpenSearch as part of the KNN. Then we have that KNN plugin in the managed service. And then the recent preview is like bringing up that KNN or the vector search within the serverless.
Great. Thanks, Prashant. Thanks, JJ. That's it for questions. I'll turn it back to you two to wrap for today. Thank you.
All right. Thanks, Bob. So with that, thank you everyone for joining. So I hope you enjoyed this session. And if there are any questions, feel free to reach out to us. And before you go, please fill out the survey, which help us to know how did we do in this session and what could be done better in future. And maybe let's hear from JJ if he had any final comments or thoughts.
No, thanks a lot for joining. More than happy to help out. If you do have any questions, like do reach out to your account manager or email one of us too, and we'd be more than happy to help out or to dive into anything that you want. It's one of the things I love to do is help brainstorm with customers to help solve your problems. So feel free to reach out and let's get you going. Have a great day and thanks for joining us.